Well, hello everybody, and welcome to Statistics. This will be our first video of this semester, and I want this video to just give you an opportunity to learn what statistics is and what it's about, and ultimately what you'll be learning this semester. Okay, so I posed you this question: what is statistics? And let me say that although I guess if you study any particular aspect of statistics, you can still just divide statistics into two parts, okay? So the first part is descriptive statistics, and I can tell you what that is and give you the definition, examples, and all that, but just think of descriptive statistics as data, maybe, okay? How do you deal with data? How do you summarize and organize data so that, it means something to you or that you can draw conclusions from it? That sort of thing. I'll give you an example in a minute, but that's what descriptive statistics is. Because before you organize it or summarize it or figure out some way to visualize it, it's just a bunch of numbers, okay? All right, so that's what descriptive statistics is. And then there's the other part, inferential statistics. And think of that as studies and experiments. So you see examples of this, both of these all the time, if you just, I don't know, keep up with the news or something like that. But we've all heard of studies or experiments that show this or that thing is true. But what we do in inferential statistics is use a sample, right? Whether you poll people informally about their preference on something or set up an experiment and give patients a particular medication that's supposed to produce a measurable result, whatever that is, that would take place in inferential statistics. We use a sample from either a poll, a survey, or an experiment to draw conclusions about a population. Okay? Does the drug really produce the result that it claims to? I don't know. If we sample 100 people, does that tell you how 10,000 people feel? Okay, so maybe there's 10,000 people that live in a certain region. If you know what 100 of them are like, can you generalize that to the entire population of 10,000? That sort of thing. We've seen this when there are elections, and we would like to predict who's going to win the election, right? You've all seen that before. But, it's like the only way to know who wins is for everybody to vote. But can you poll a small number of people, a relatively small number of people, about how they're going to vote and make a prediction about how everybody is going to vote in the end? And what I mean by everybody voting is like, can you make a prediction about who's going to ultimately win the election? All right, and obviously that's not a perfect science. There are examples when the predictions have been wrong, but inferential statistics is the branch of statistics where we study the best mathematical ways to use a sample to draw conclusions about a population. Okay, now I want to give you an example on descriptive statistics. How do we make use of data? How do we organize it, summarize it? How do we display it or visualize it? Let's do that first. Okay, so here's some real data. So these are from last semester. These are the final scores in my Math 13-14 class, which is algebra, spring 2022. So these are the actual grades. So these are real data. So it's not numbers I made up. Now, whenever I just downloaded the grades from Canvas, this is how they're given to me. It's just a bunch of numbers. We call that raw data. It's not organized. And just with the numbers as they are, it might be difficult to visualize it or draw conclusions from it. I guess you can, at a glance, look at it and say, well, somebody got a 99, and it looks like the low score may have been 60, but imagine if the data set were much bigger than this. It'd be hard to draw some immediate conclusions from it. Okay, so that's what raw data is. And as I told you, the way that it's given, it's difficult to draw conclusions, to see what it means, or to visualize it, okay? Now, there are several things that we can do, but But one thing that we might do with raw data like this is make something called a frequency histogram, okay? And with that, what we are trying to do is make a kind of a graph where we can look at the graph and judge how many students scored in various ranges. So like from 60 to 68, one score; from 68 to 76, one score; from 76 to 84, there were 5 students, and so on. So this gives us a way to visualize and organize those numbers, okay? Because before, they were just a bunch of numbers that seem more or less random. I mean, it went from 93 to 60 to 85 and so on. And this is one way that we can organize it, all right? And there's really no magic to making one of these. I mean, you divide up the space from 60 to 99 into this. I did 5 groups, 1, 2, 3, 4, 5, and I counted how many students were in each group, okay? So there's no magic to it. It's not like it's that difficult, but it goes a long way as far as organization. It's much easier to see what those numbers are like this way than it is this way, isn't it? Okay, so that's one thing that we do. And another thing that we do is this. So here I've reproduced those same numbers. Remember, this is raw data. These are the final scores for Math 13-14 Spring 2022. So another way that we might summarize it that's not visual, because remember, the frequency histogram is visual, all right, is by giving numbers such as the mean and the standard deviation, okay? All right, so these are our single number summaries of all of the data. So think of it like this. The mean tells you where the numbers are. So think of it like this. You see these numbers, the raw data? Are most of those scores close to 40? No, it doesn't look like it, okay? Where are the numbers? I mean, I know that all the numbers are different. Most of them are different. But, like, do they seem to cluster around a certain spot? Like, are the numbers closer to, like, 85, or are they closer to 45? See what I mean? So the mean tells you where the numbers are, all right? And we say that that number is a measure of central tendency of the data, okay? The data is lots of numbers, but it might be nice to say what they're close to or where they are, okay? All right. Now, the way you calculate the mean, you might know this number already as the average, okay? So the way you calculate the mean is very simple. We add all these numbers together and we divide by how many numbers there are. Now, at some point, we'll have a lesson devoted to just calculating numbers such as this, but for our introductory video today, I just wanted to tell you that, here's a number that tells you where the numbers are. Now, what else might there be to know about the data as far as quick summaries go? Well, could the numbers be close to 85? Or could they be more spread out? Okay? So, like, if I say, if 4 and 6, the average of 4 and 6 is 5, okay? But, I could have something like 1 and 1 and 9 and 9 or something like that. And let's see, the average of that is also 5, okay? Yeah, I can do some math real quick. 18, 20. Okay, so here the mean is 5, meaning that these numbers are close to 5. And here, if you calculate the mean, it's actually also 5, all right? These numbers, we'll say, are close to 5 as opposed to being close to 20 or 10 even. We can't say the mean's 10 because although the 9s are close to 10, the 1s aren't, all right? So that's why the mean is a measure of central tendency. But, these numbers are close to the mean. These numbers are close to the number they cluster around. And these numbers aren't. Okay, these numbers still cluster around 5, 1 and 1 and 9 and 9, but they're not very close to 5. So then that gives rise to this other number called the standard deviation. Okay, so let's think of this then. Just to put it simply, for this first video, we'll talk about it in more detail later, but this tells you how far apart the numbers are. Okay, the bigger this number is, the more the raw data is spread out. Okay, so let's see, 4 and 6, those numbers are not spread out. 1, 1, 9, and 9, those numbers are spread out. Okay, but when there's all these numbers, the raw data, I'd like to know, well, where are they and how far apart are they spread? Okay, that's what the mean and the standard deviation tell us. So those are like single number summaries of the raw data. Now, no matter how big the raw data is, this could be like 1,000 grades, okay, or whatever. You can still calculate the mean and standard deviation. Single numbers. I can still calculate one number that tells you where the numbers are, and I can calculate one number that tells you how far apart they are spread. Okay, these are just measurements. These are just calculations, but they tell you something qualitative, as I've described there. All right, now so that is descriptive statistics. Okay, I showed you an example of how you visualize data. How do we do that? The frequency histogram. It's a good way to visualize data. Okay, and then I showed you how to summarize data or organize it, okay, in the mean and the standard deviation. Numbers tell you where the data is, or the data are, and how far apart they are. All right, now let's look at the other branch of statistics, inferential statistics. Remember I said studies and experiments. So here's an example of that. So let's suppose that students are taking the SAT, and there is a school, okay, that claims that if students take their course, okay, then they'll improve their SAT score. So it's an SAT prep course. So you'll get like a before and after result. So they say if all students that took our prep course improved their score on the SAT by such and such. All right, so here's some data to establish that claim. The students have their first attempt. Here's their score for their first attempt. So student number 1 scored 308, okay, on their first attempt, and student number 1 scored 408 on the second attempt. Well, that's an improvement. I mean, the claim is there's this SAT prep course, this school that offers this prep course that claims to improve the test scores. All right, that's an improvement. What about student number 2? First attempt, they scored 456, and second attempt, they scored 524. Well, I would say that's an improvement too. Now, I guess the problem with numbers like this is that they could be by chance. The improvements could all be by chance. Or luck, you might say. Maybe it wasn't the prep course. Maybe it was that students were familiar with the test. They'd already seen it and they knew what to expect. That's why they did better the second time. Okay? Not because the prep course, just because of they knew what to expect. Now, you see claims like this all the time, don't you? That such and such product or service offers a before and after improvement. All right, well, how do you really know that that improvement is because of the service? It could be luck. It could be because of something else that's unrelated. And here, maybe we can see that. Maybe that improvement is because of the prep course. Maybe it's because they knew what to expect. Maybe it's something else. Maybe it's a combination of factors, right? So here's what we use inferential statistics for. Here's the goal of inferential statistics is, sure, there's improvement, but we need to know, like, how do you really quantify how much improvement there was? Like, is this improvement does it really give testament to the SAT prep course? Okay, so we got to measure the improvement somehow. As I mentioned, could the improvement that we see there, if there is improvement, just be due to chance or luck? How do we know that? I mean, if that's a possibility, we would want to rule it out somehow, okay? Could the improvement be because of some other factor besides the prep course, right? Okay, so those are all the things I said could be going on here. So yeah, I need to do something with these numbers, and then I need to do something with the experiment itself to prove that what happened is really due to what's being claimed, that the SAT prep course is what led the students to be better. Okay, so that's what inferential statistics is about. Like we call this an experiment. It has a before and after result, and we need to figure out, study, learn ways to draw conclusions from that. Okay, all right. Now, I guess you could say that in our class, the first half will be about descriptive statistics, and the second half will be about inferential statistics. All right, but that's what either of these is going to be about. So whenever we're learning any particular thing, any particular concept or mathematical formula or whatever it is, it'll fall into one of these. And even if it seems a little bit confusing at the time, eventually our goal will be to step back and look at the big picture and see how it fits into this first video. All right, because everything that we'll learn is going to be like the examples I gave for descriptive statistics or the example I gave for inferential statistics.